So this triple Venn diagram problem requires you to read the question really carefully and interpret it. And I'm going to use the three circles to represent these regions. So let's say this is math, English, and this is history. And they tell us that there are 28 students taking at least one subject, meaning the outside area, there's no one, meaning all of the 28 students are included in these three circles. And then we're given that the number taking math and English only, so that would be this region, math and English only, equals the number taking mathematics only, which is this region. So I'm going to call it some variable, let's just call it y. So these are both y. And as a rule, I only represent the quantity that describes that particular region. So when they say English only, that would be this region here. And I think that way you just have to add the different regions to get the total or any other quantity that you need to find. The next they say no student takes English only, so which means this region, this is 0, or doesn't exist, or history also, so this is 0. So that simplifies this problem quite a bit. And it says, and 6 students take mathematics and history, but no English. So that would be this. So no English, because English would require this region here. So that's mathematics and history, but no English. And it says the number taking English and history only, so English and history only, which is this number here, this region, is 5 times the number taking all 3 subjects, which is that here. So this would be 5z, again, representing this region here. And it says if the number taking all 3 subjects is even, which means z is even and is non-zero, the number taking English and mathematics only is, so English and mathematics is really, we want to know what y is. So essentially most of the work is in interpreting and translating the statement, and now the condition is that 28, which is the total number of students, is the sum of these different regions. So that would be y plus y, so 2y plus 6 plus 6z, adding these two. So that would be 2y plus 6z, and I'm going to subtract 6 from both sides, that's 22. Divide throughout by 2, so that becomes y plus 3z is equal to 11. And they tell us z is even, non-zero, so the smallest value of z is 2, which means this is y plus 6 is 11, so y could be 5. And then we say, okay, next, we just have to make sure that the next possible higher value of z is 4, which would make this 12, but then y would become negative. So that condition constrains y to be equal to 5. So the correct answer is choice A.